Okay, guys, we're going to go ahead and look at parameter changes for rational functions. Now, we've been studying parameter changes all year long. So remember, the A value, what does it do to the graph? The H value, the K value. We're going to be looking at all three of these again as it relates to the rational function. Remember, what makes this a rational function is the x in the denominator. So we want to sketch a graph of the following without using a calculator. Okay, don't forget to label the new reference points and to write the equation of the new asymptotes. Okay, so first of all, the domain. Remember, in order to find the domain, we take the denominator, we set it equal to 0 and solve for x. So the domain will be x is an element of all real numbers such that x does not equal 3. Because when we plug 3 in, 3 minus 3 is 0, and you can't divide by 0. Okay? Remember, rational function has a horizontal asymptote as well. Notice the degree of the numerator is less than the degree of the denominator. The degree of the numerator is 0. The degree of the denominator is 1. So the horizontal asymptote, which isn't here, is going to be y equals 0. Let me write this down here. So horizontal asymptote at y equals 0. Okay, and then we have a vertical asymptote. Remember, that's going to be your x equals 3. That's going to be your vertical asymptote. Okay, now the point that we're going to translate here using our h and our k is going to be, we're going to always start here at 0, 0. We start at 0, 0. Might want to write that down. When translating, we start at 0, 0. Okay? So this says to move 3 units to the right. So 1, 2, 3. 3 units to the right. And that's going to be our vertical asymptote right there. And then our k value is 0, so we go up 0 units. So where that brings us, right here, that brings us to the intersection of our horizontal and our vertical asymptotes, the intersection. Now our a value is 1. So from this point, we're going to go over 1, okay? And then we're going to go up 1. And then we're going to get this part of the graph right here. Okay, and then to get the other portion, we go to the left 1, and this time we go down 1. You might be thinking, well, hey, Mr. Kramer, it's positive 1, right? But if you go left 1, that's negative 1. And if you go down 1, that's negative 1. And negative 1 over negative 1 makes up positive 1. Then we make the other part of the graph right here. Now, here's what it looks like on my calculator when I plug it in. Okay, that's what a rational function looks like. Okay, I plugged in the 1 over x minus 3. Now, the parent is going to be 1 over x. So, graphing that, notice 0, 0 is our starting point. Here's our horizontal asymptote. Here's our vertical asymptote. Okay, h is 0, k is 0. Range. So notice it goes down infinitely and up infinitely, but it doesn't go through 0. So range, similar to x, we're going to say y is an element of all real numbers such that y does not equal 0. So let's make a connection here. Now, when we're in this format, okay, when we're in this format, we can get this number here from the h value right here, the 3. We can get this value from the k value, which in this case is 0. So you can get that value here from the k value, and this value here from the h value. Okay? All right, you try number 2. Let's see what's on the other page here. We'll do these in class, so no need to do that. Number 5, it says describe how the parent graph is shifted to get the graph of -1 over x. What is the domain and range of this graph? So I think what I'm going to do here is, rather than, because I want you to do these in class, I'm going to make one up, turn it over to the back, and let's write a function here, a rational function. We'll do a little bit of everything, shall we? So, right off the bat, our a value is 2. It's greater than 1, so remember we have a vertical stretch. Okay? The negative. That means we have a reflection over x-axis. Okay? H value, 1. That's going to be a translation. Translated. Remember, it's always the opposite. This is a group. So when we pull a number out of a group, it's going to be the opposite. So translated 1 unit right. And remember, that's associated with the vertical asymptote. So that would be x equals 1. It's also associated with the domain, okay, where x does not equal 1. And then our k value is what it is. It's 4 units. It's translated 4 units down. And remember, that's associated with the horizontal asymptote. So we would have y equals -4. Now, if we were to graph this, remember, where do we start? We start at 0, 0. So we would go 1 unit to the right. So 1 unit to the right. And then we go 4 units down. All right, so that's our new center. Remember, that's the center of our asymptotes. So there's our horizontal, there's our vertical, and then to graph it, we go over 1 unit, and then our a value is -2, so we would go down, so over 1, down 2. So notice there's a reflection. Okay, so then we would go over the other direction 1 unit and up 2. And that gives us the other part. Notice the graphs are always diagonal from each other. Last page. Given a function, find these values of the function. So simple. Remember that the value within the parentheses, that is our input. So all we have to do is input that value into our function. So we would have 3 over 2, inputting the 2 in for x, and our answer is 3/2 or 1.5. Okay? And that's how you do that. Let's do one more. Let's plug -3 in. We'd have 3 over -3, which is -1. And finally 0. Plugging 0 in, we'd have 3 over 0, which you cannot divide by 0, so we say this is undefined. All right, have a good night. We'll see you tomorrow.